Okay, so this week we actually have a pretty small week. We're looking at our assessment problem and our assessment problem and our goal reading. So this lecture is going to focus primarily on our assessment problem, and I'm going to pull up the assessment problem 1 here just a second. So you're going to see my screen pause for just a moment. Okay, so our assessment problem gives us a set of data, and what I've done in this particular one in Excel is to input the information. You will notice that your answers aren't going to be quite like these ones, so I did modify one of the data sets just slightly so that it's a little bit different for us. So what we're going to look at is what is SSE, SST, SSR, and what exactly is the problem looking for. And when you're setting up this problem, I recommend having a summary page similar to this. You'll see not all of the answers are in here. I started to just give an example of what the summary page will look like so that you can print this to PDF. The other alternative and the other video for the assessment problem goes into how to complete this in Excel. So if you're using Excel, I encourage you to watch the Excel video. Or this one, I'm going to demonstrate how to complete this in POM QM. So regression analysis is essentially one way for us to forecast or predict. Regression analysis is useful in determining causation versus correlation. So a good example of causation is, does one thing predict a change in another item? So this problem is asking, to start with, does square footage predict the selling price, or is it just a correlation? In other words, just because square footage goes up does not necessarily mean that selling price goes up. There seems to be a correlation there with higher square footage leading to, or higher square footage and higher selling prices at the same time, or is there an actual prediction, a causation? So for every square foot, selling price goes up X number of dollars. So we're trying to determine, 1, causation versus correlation, and 2, what is our best method for predicting selling price? Is there a way that realtors can ultimately look at the key factors of a business and determine selling price based off of, or of a house, and determine selling price? And the problem has part A and B. I have the data in here from both parts A and B so that we can look at the 2 different methods that we're going to use to complete our problem. So the first thing it's looking at is, does the SSR, what is the SSR, SSE, and SST? So in a particular problem, or in a regression, and I'll pull up this slide really quick. In a regression, there is an explanation of the data. So this is our line, and you may remember this from algebra: y equals mx plus b, or y equals a plus bx, however you want to word that. But we're looking at the point y, so what we're trying to predict lies on a line that's calculated by slope plus the multiplier of x. So what is it that we're trying to determine predicts y? So in the first one, the equation is going to be price equals the slope of the line plus the multiplier of square footage multiplied by the square footage that we're trying to determine the price of. So there are two types of errors that occur, or two types of explanations. There is the deviation that's explained by the regression, so this portion of the data down here. The difference between Y and the actual line. This portion of the data is explained by the regression analysis. In other words, there's a relationship there that our regression analysis explains. And then there's a portion of the error that's unexplained by the regression. So we have our SSR, the sum of squares regression, which is explained by the regression, and our SSE, the sum of squares error, which is not explained by our regression. And then our SST, our sum of squares total, is the total deviation around Y. So all of those points above and below Y that are either explained by our regression analysis or not explained by our regression analysis. In Excel, and again, if you want to run this in Excel, I encourage you to watch the Excel tutorial on how to do regression analysis. In Excel, we find our SSR, SSE, and SST in our summary output. And then we also find our F, our significance of F. So is the data statistically relevant? That would be our significance of F. You may get a report that shows, for example, 2.7 and negative 5e. That means you need to put 5 zeros in front of the 2.7. We consider significant at 0.05 or below. So this case, we would alter that to 0.00002, and we would say that this is significant. And then we have our multiple R and our R squared. So is the 70% of our data, so to speak, in this case, can be explained by our regression analysis, so that square footage accounts for 70% of the change in price. So this is a pretty good relationship between square footage and price. Our intercept here is the coefficient, so this is our A, or sorry, our B. So in Y equals MX plus B, our intercept, Y, or selling price, equals our square footage multiplier, so our coefficient here, coefficient of square footage, times our X, which is selling price, or sorry, which is square footage, plus our intercept. So I would write this equation as Y equals 50.69 X plus 27,528.81. And we're doing this in dollars, so we're only going to use 2 decimal places. So then if, for example, I think one of the questions asks, solve for a 2,000 square foot home, we would use Y equals, and again, these numbers are going to be slightly different than the ones that you have. This is an example of where to find the data. 5.69 times 2,000 square feet plus 27,528.81. So then you could solve this equation for the selling price or Y. And estimate what our selling price would be. So let's go back to our data, and we're going to go to POM QM. And I like to put the data in Excel or some other spreadsheet because then it's easily copied and pasted into our POM QM. And to solve this problem, to work through the entire assessment, means that you're going to have a total of 6 results. Just the square footage alone, bedrooms alone, age alone, and then you're also going to need to solve a multiple regression for square footage and bedrooms combined, bedrooms and age combined, and square footage and age combined. So we need to do 6 total runs then in POM QM. So having the data readily or easily copied and pasted into POM just makes it a little bit faster. So first, let's take a look at we have 17 data sets or 17 samples. We're going to go into module. And this is a forecasting method, so we're going to choose forecasting. And then we're going to start with File, New. And we're doing a least squares, simple and multiple regression. And the first one, and we need to select our 17, and I'm going to label this square footage. And the number of independent variables. So our dependent variable, what we're trying to predict, which is our Y, is price. And right now we're only looking at one independent variable. Does square footage predict the price of a house? So we're going to leave that at 1. We say OK. Oops. We need to go back because I put 7 instead of 17. One variable, square foot. Okay, so now we have our dependent variable, which is price, and our square footage. So I'm going to label these so it's a little bit easier in the output to determine what I'm reading. And I'm going to flip back to my Excel spreadsheet, and I'm going to copy price and square footage data. And paste it in there. And then I'm going to click Solve. And so this is giving us quite a bit of information right here. Here is our regression line formula. Price equals our 27,528 plus our multiplier or our coefficient of X times our square footage. So Y equals B plus MX. So this gives us the solution to one of our problems all right off the bat. Then we also, and here's also our correlation coefficient, how close does the data rely together, and then our coefficient of determination, how much of the data, so how much of the square footage determines price. So we have both of these right here handy. And then we're also going to go to Window and look at our sum of squares computation. And we can widen these out. And we have our SSE of 67, our SSR, and our SST. And as a quick double check, SSR plus SSE should always equal SST. So now we can save this as an HTML or save this to Excel so that we have one side of our workbook completely done. And we can move on to the next one. So you would need to repeat this for price and square footage, price and bedrooms, and price and age. So I'm going to close these, and to do those initial ones, we already have price in here. So now, once I've saved that, I can do age for example, and then come back to my data and copy this and paste my age in. Oops. Got to watch POM. Sometimes it can be a little bit tricky. Our first one is just 30. And now I can solve for age. Let's make sure we have the correct information in here. And again, yours are going to be a little bit different because I edited some of this data. So what we have here is that there's a negative correlation, meaning that the older a house gets, the higher number in age means a lower number in price. So the older the house gets, the lower the price. The newer or the lower number of houses, the higher the price. All right, so then we want to start a new one, because now we need to see we're just going to get rid of that screen. We have the same 17 observations. Now we're going to see if two items together better predict our selling price. So we say okay. And we're going to grab selling price, square footage, and age. I'm going to paste those in there. And again, I'm going to label them. And we're going to say solve. So now we have a little bit of a different equation because now we have two x values. So we have the coefficient of square footage multiplied by our square footage, the coefficient for age multiplied by our age. And again, this is a negative coefficient because age has a negative relationship. And then our slope value of 94,608. So now we would write this equation, and I'll go over here to square footage and age. So we would write this equation of y equals the coefficient for square footage multiplied by square footage plus the coefficient of age multiplied by age plus our intercept, or y equals 31.28 times square footage plus negative 1491.14 times our age plus our 94,608.30. So now we have a new y equation, and if we wanted to solve for a specific data set, we could say that we could input the square footage of the home and the age and estimate the selling price, assuming that this particular data set was relevant and meaningful. And again, we can go to our window and look at our sum of squares and look at that portion of the data that is explained by the regression, that portion that is not explained by the regression, or that portion which is error, and then our total data set, or total sum of squares. So there are a couple of different questions that the problem is looking at. One is, what are some factors that could be related to selling price or could be used to predict selling price? And the problem gives you a couple in Part B, but the question actually comes before that Part B section. So it wants you to think creatively about what factors may relate to selling price that should be explored to estimate selling price. And some may be hard to quantify. So for example, location. Location may certainly relate to selling price, but we can't use location as a predictor because there's no way to increase or decrease unless you're using numerical values like location 3, location 2. And that's an entirely different type of interpretation that you'll get in the statistics. But for this case, we could use maybe distance from a set location, like distance from an urban center. So 30 miles out versus 60 miles out. Does an increase in distance from urban lead to an increase or decrease in price? So that might be an example that you use for factors to explore in selling price. And then it also starts to ask you to develop an ideal model then. So we need to look at, when we're looking at these pairs, we need to look at our R and R squared. Which pair has the highest coefficient of determination and the highest correlation coefficient? In other words, which pair shows the strongest relationship between the data and the outcome? Which pair most likely predicts the selling price? And why is that pair? So one of them you'll run into in the individual analysis, which is why it's important to do the individual analysis for all three before doing your multiple regression for your pairs, because one of them has a very poor relationship with selling price. And you'll find that that one actually drives down the correlation coefficient in the multiple regression analysis. And so that's going to be important for you to explain in that Part B as to why you chose one pair over another pair. Because the one item that you leave out in the pair that you chose is going to be the one that has the worst relationship, or the worst R squared, the worst coefficient of determination, and the worst correlation coefficient. In your individual analysis will have driven down the other two pairs. So once you've completed all 6 of your items, and again, you can save it. You can either do a print screen with your data. This is going to be the most important screen, the forecasting results. You only need the SST, SSE, and SSR for the square footage one in Part A. So this is ultimately going to be your most important screen for your homework. You can do a print screen and put each one of these summaries in a Word document and then summarize. Again, it's really important. If you do it in Excel, you can do a summary page like this. If you do it in POM QM, you can do individual print screens with your summary data, but it's still important to have the summary page where your questions are going A through M and you're answering them in a summary so that it's easy to follow and understand. When you do need to do the chart or detail analysis, you may need to put your results in Excel to do an Excel chart. Let's see if our least squares with a single is going to give us a chart. So we have 17 observations, 1 independent variable. We're going to grab our selling price and square footage. And solve. And there you go. So it does have a graph for you. You can put this in your Word doc to submit as your graph, which helps with a portion of the homework problem. So I hope this helps going through this in POM QM and to explain some of the questions and what it's looking for. As always, please feel free to contact me if you have any questions.